Welcome everyone to this webinar on managing databases to drive application performance. I'm your host. My name is James Brown. I'm a product manager for Claranet, working on hosted applications. The reason we are bringing you this webinar is discussing databases is that they are a vital element of business application suite, and we feel it often goes unnoticed perhaps. They're left to run in the background, working as the unsung hero at the center of business, but often only receiving that attention when things go wrong. So, fundamentally, databases are there to support the business. So we'll begin by considering some of the reasons why we feel databases can be used to gain business advantage and explain why we are so passionate about showing databases the love they deserve. We will then go on to discuss what needs to be done to ensure the database is driving the business forward rather than holding it back, and that's in terms of maximizing availability and performance without making compromises to data protection. We'll illustrate, I think, a bit why there's a sort of black art to database administration and why the expertise exists out there is so valuable. Okay, so I'll now let our two gurus introduce themselves. Over to you guys.
Good afternoon. My name is Brendan O'Connor. I've been 4 years at Claranet as a database administrator and 10 years in total working as a DBA. Mainly I work in SQL Server and currently look after hundreds of servers with literally thousands of databases on them. My tasks in general range from monitoring systems, advising clients, to setting up multi-server solutions for clients.
Good afternoon, my name's Andy Watson. I work for Ardenta, who are a Claranet group company, and I've been with them for 14 years, mostly as a DBA, working in the e-gaming sector, which has a very high emphasis on security, availability and performance. Over those years, due to its high level of integration with the operating system and SAN around it, I've also picked up expertise in those areas. So now my role is around solutions design for new operators or the strategic platform development for existing customers.
Great, okay. Thanks for those introductions. I just want to start us off with Brendan. Can you talk to what is a database?
Yeah, well, a database is essentially a collection of data that's collected into structures, and these structures generally have relationships between each other, which then allows people to query the data in different ways. Now, you get varying degrees of relationships and structures nowadays because the information that is held basically is subject to a lot higher degrees of flexibility, and we need the ability to adapt the structure, often very dynamically. The application requirements affect what type of technology we use and the application design, but fundamentally the same principles for availability, optimization and data protection still apply. And to put it into context, effectively a database is like a cutlery drawer. You have containers for each element, the knife, the fork and the spoon, but as we can see from the photograph above, these can get a little bit messy over time, and our job is essentially to make order out of this chaos.
Okay, can you go on to explain the purpose of database?
Yeah, sure. There's a lot of different roles the database can play, and because there's so many different ways the application can use the data, but for the purposes of this webinar I'll basically make two distinctions. The first one is called OLTP, Online Transactional Processing. Basically this is a lot of small requests in the database which return quite a small amount of data that needs to be completed in a very short space of time. So this is things like ordering systems, ticketing systems, and things like that. You've also got DSS, decision support systems, and this is normally a small number of requests but larger data sets each time, and these take longer to complete normally. And these are things like reporting systems and any system basically where you need a lot of data to look at leisure.
Okay, thanks, Brendan. So over to Andy. What's good database management, and why does it matter?
So personally, from a business perspective, I think that the database is typically overlooked because it's a long way down from the front-end applications that people see either on the website or in their applications back in the office. The application developer normally has a lot of pressure heaped on them to drive out new innovations and enrich end-user experiences, create new sources of revenue and markets with a faster time to market, create points of competitive differentiation, and by combining all of these, strive to increase customer loyalty. We feel that the database is pivotal in supporting this for two main reasons, really. Data collection now is pretty cheap to do. It's really easy to gather information on a whole range of aspects of your business, from player profiles or individual usage of your systems. So all that data can be held within the database and lots of value can be extracted from it. Take, for example, sports betting, where I do a lot of my work. There's a lot of emphasis now on player profiling. So enables them to understand what the players like to bet on, what times of the week they bet on it, whether they have a particular preference for players or whether who's going to score the first goal, whatever it might be that person particularly likes. By understanding that, they can target them with a particular interface and particular bets that really suit the way that they operate and at the time that they want that information. One operator has taken that to the extreme, where they've developed their platform to look a lot like Tinder, where they'll present very tailored bets to the individual, and the individual swipes left to decline the bet, or swipe right to accept it. The database is key in holding all the historical information that made it possible to do this, and the real-time analysis to enable them to target it at the particular user at the particular time based on the particular events that are going on there and then. The second reason we feel it's very important is that if you've got a database platform that's underpinning your entire application stack, if you have a high level of confidence in its availability and the performance, then you've got the confidence to invest in that platform, invest in the applications above it, and continue to rely on that to drive and run your business.
Thanks, Andy. With that thought in mind, you've highlighted how crucial database uptime is to these business benefits, which get the attention. So just before, Brendan, I'm going to ask you a question on staying online. Just like to remind and tell all our attendees they can raise questions at any time in the panel. If they just type their questions into the GoToWebinar panel, we will pick those up at the end. So back to Brendan, how do databases affect the availability of front-end applications?
Well, I just want to make sure that everyone sees the difference between system administrator, who's normally skilled in managing the operating system in which the database runs, and who might learn basic database administration skills such as restarting database systems, and an actual database administrator. I'm only saying this because from a business perspective, the database is often considered fairly low down on the infrastructure stack, as it's perceived as being far removed from the front end that users often see. However, that changes if there is a database issue. It's often very quickly then propelled up the chain, as the impact to the ability to deliver front-end service is very tangible, and basically if the database isn't performing, it can stop everything else performing.
Yeah, so a DBA will worry about the system all the time, whereas the business is more inclined to worry about it when something's gone wrong. So for all the work that the DBA does in the background, proactively trying to avoid problems, inevitably problems do occur, and when those problems occur, they have a huge impact. And it's at that time where you really want your DBA there, someone with the expertise to troubleshoot a problem and implement a remedy to minimize the downtime and impact, because that is where a DBA has real value in protecting your revenue and your reputation.
Absolutely, and as you've already alluded to, what are the best practices to preempt these problems?
I suppose the first thing to be aware of is that modern database technologies and platforms are very good. They will run unattended for large periods of time, but my experience is that if you do that, you will get stung eventually. Problems build up in the background, and probability being what it is, they will surface at the least convenient time for you, and that's when it's going to hurt you the most. So you want your DBA to be constantly working on things in the background, and the sorts of things they might do, for example, capacity planning and provisioning. This is really important, obviously, for the long term, but also for short-term spikes in activity. And in today's world, where there's so much emphasis on agile application development and agile businesses, there's just a whole raft of new unknowns in there about the way that your platform is going to operate and what it needs to be able to do. So you need to be on top of your the available resources and make sure you've got plenty of headroom there to absorb these short-term spikes that you cannot predict.
Yeah, and in any database management system, you've got to be aware of the limitations of hardware and products. DBA's got to be aware of all these limitations and understand how exposed their database is, and also what type of steps they need to be able to mitigate any impacts. One example of this is one of the technology we use has a limitation on the amount of storage space that can be put in a single table. If that limit is reached, no new data can be inserted, regardless of how much physical space there actually is. And this is an extremely difficult thing to mitigate after the event. So the database administrator's job there was basically to monitor when these limits are being reached and then ensure that they've got capacity to store the data and adjust the way it addresses things. Data in this case is stored in a lot of different types, numerical or characters, and if the data type only allows a certain size of number, when that's reached, the application throws errors. So once again, the database administrator there is proactively identifying when there's an issue and to mitigate the impact. After the event, though, a lot of these approaches are reduced. So then it's a case of a database administrator really trying to rescue a customer from a problem that could have been foreseen.
And finally, I think that it's really important that the database administrator is keeping an eye on new releases from the database vendor to take advantage of new functionality, patch to relieve bugs or security issues. So they should be constantly reviewing this information, developing test plans, working with application developers in other areas of the infrastructure so that they can test that functionality in an environment that represents their production, so that they can have confidence that the results carry through into live and the business actually starts benefiting from those.
Thanks, Andy. And that's the moving on to the next section. Moving on to performance optimization. Brendan, what performance best practices do you recommend, and how does database performance complement application performance?
Well, it's certainly the case that good application code's very important, and a system administrator can show how that application can relate to the hardware. But a good DBA can work alongside both of these people to get the most out of the application. The whole purpose of database management system is to ensure data is stored securely, is easily accessible, and can be brought back as efficiently as possible. There's lots of mechanisms in place to help that, and one of the key ones is indexes. Now, these operate in exactly the same way as in books. You can index on chapters, you can index on pictures, you could index on particular words. After a while, you can actually have more indexes than there are pages in the book, and then it becomes extremely complicated to try and find a certain piece of information. And this happens in exactly the same way in databases. So our job there is basically monitor the way the databases are being used, look at the way the indexes are being used, and continually address problems like over-indexing or indexes that are no longer fit for purpose because the queries that are being run have become redundant. And so the indexes on the database then we can just remove and add ones that are of more benefit.
A database is made up of many different tables, all of them with data that are related to each other, and so queries generally don't just retrieve data from a single table. They'll generally combine data from numerous sources. This means that the database has to make a decision about the most efficient way of getting that data back, and it does that by forming a query plan. So that will determine which order it goes to the tables, which indexes it will use, whether it'll even use any indexes. And the way that it makes those decisions is based on statistics. And those statistics are things that the database administrator must gather. He must schedule the process to collect them and determine the frequency he collects them, the level of detail on each table or index that must be collected, and all of those decisions are made around a detailed knowledge of the data within the database and the resources that are available to it. This helps you take an example of a large table of 10 million rows. It makes much more sense to go and query it via an index to pull out the one or two rows that you're interested in. If you've got a small table with just 10 rows in it, it's just as quick just to read through each one of those rows in turn until you find the ones that you want. Those are the sorts of decisions that the query plan helps.
Yeah, and there are even times when accurate statistics don't actually lead to the best query plan. So the database administrator then has to look at the plan manually and take some steps to ensure that the best plan is adopted. This can be things like just adjusting the way the statistics are collected. You can actually provide hints in the queries so that the data is looked at in a different way. You can rewrite the query or revisit the way you index and perhaps put a few more columns in the index. All of this requires quite a detailed understanding of the way the database works and the relationships of the data.
Okay, that's interesting, Brendan, on the sorts of things that sort of information you guys do. It's certainly interesting to go that a little bit deeper for me. But when it comes to performance optimization, aren't we bound by physical resources and available hardware? Andy, can you comment on that?
Yeah, I mean, it's certainly my experience that inefficient query plans have a devastating impact on performance, and that if there is such a thing as a silver bullet with databases, then it's statistics and plans, but hardware resources come very close in line to that. So it's very important that the DBA is aware of the resources available and the best way to tune those. And tuning is generally a balancing act. between the resources you've got available, of the types of queries that you need to service, what the business view as being your key objectives, because it's not normally possible to serve all your masters. In order to do that, you need to have very detailed monitoring in place so that you can see exactly the impact that different tuning objectives that you put in place have, and that you're able to benchmark how the system performs. You wouldn't want to go and make one process 5 times quicker at the expense of making another 50 times slower, for example. It's then very important to understand the type of database and the way that it's used. So we talked before about online transaction processing systems, the short, sharp, frequent requests, as opposed to the DSS and decision support style systems that are all about reporting, where you have fewer, longer running. Those two types of systems have very different tuning objectives, and you need to bear those in mind.
Yeah, and over time, as the database grows, the data becomes a lot more distributed over the disks. So related data is no longer even stored together. And this has a direct impact on how quick it is to retrieve data. Basically, to query the data, you have to go physically and collect it from different parts of the hardware. Identifying this, removing this fragmentation, allows the database then to carry on a lot more efficiently and also do more with the same hardware.
And then this is quite a confusing area, because on the one hand, the database administrator is trying to eliminate fragmentation, and on the other hand, they might well choose to deliberately fragment their data. The reason they might well do that is varied. So one is by distributing your data across various hardware resources or into different areas means that the database can initiate separate tasks in parallel to serve one function, meaning that you can make more use of the available compute or I/O resources that are available to you. Another reason would be for write performance. You might decide to distribute your table in a round-robin style, so it writes to one area, then writes to the next and the next in turn, again balancing resources. Maybe for your environment, actually read is the most important, and so you could use something called fragment elimination, whereby you order your data across the hardware in a manner that matches the way that you're likely to query it. So if, for example, you've got all the sales data for the UK, but normally you're interested in querying it around regions, then by fragmenting the data across those regions, when you're looking at the London region, for example, you can immediately disregard all the data that's related to the rest of the UK and therefore put less strain on the hardware and retrieve better results as a result.
Okay. Another area is, if you understand the relationship between hardware and data, you can then target the resources where they're most needed. For example, a lot of databases have temporary space, temporary databases used to hold volatile data. By volatile, I mean things like when you order a result set, that ordering takes place in temporary area. Now, the speed of this has a direct response on how fast your query is. So when you're doing operations like this, you might want to store the temporary database on SSD, or because it's volatile, you could actually use things like in-memory file systems instead, and this would get a far superior memory response and speed.
Okay, thanks, Brendan. Now on to the last section, in the last question in this section. When, in your experience of dealing with so many businesses, when better performance and availability are achieved, what will the business feel as a difference?
Well, one big factor there is efficiency and also end user perception, and this can directly encourage loyalty and affect the bottom line. We can also talk about the innovation Andrew mentioned earlier. Because you're confident that your system is delivering, then there's less risk in innovating, and so you can move your business forward. Well, it also has a direct impact because you're not using as many CPUs perhaps as normal, and CPUs are often licensed. So if you can make your queries more efficient and faster, you're just paying less licensing fees, and also you can minimize your hardware costs, whether that's pay-as-you-go on the cloud or data center space that you own directly.
Okay, thanks, Brennan. So that's interesting stuff on availability and performance. So now on to our last question, our last section. Andy, what are the options around removing the database as a single point of failure?
Yeah, so I think we've established that the database is very key to the business, and all things end at the database in a lot of environments. So we do a lot of our design work around removing the database as a single point of failure. When we're designing the systems, we always try and take a step back first and go back to the business and ask them questions about what they want to achieve. What level of data could they afford to lose if something went wrong, and how much downtime could they afford in recovering from that failure? Because there's a plethora of options available in terms of, with different levels of complexity and cost, effect to licensing, and you need to understand your business objectives in order to pitch at the right level to ensure that the business actually understands the impact of making sweeping statements about the level of protection they need. And that will ultimately help you decide whether you want to use an operating system or a database cluster, whether you want to replicate at the database level or the SAN level, or whether you can rely on sort of native database backup and restore tools, or what the most appropriate combination of those is for you.
Yeah, and the initial reaction often is we want zero downtime and zero loss of data. And that's a discussion point. But that type of thing can come at a significant cost, and often when that's presented, we then get a revised statement of what the objectives are. And our job then is to work through this. And it's important to understand that not all failures have the same risk or likelihood. So, although it's probably the case that some businesses can't afford to lose any data or have any outages for individual hardware components, such as disk drives, they might have to accept a larger impact if the failure is something like the loss of an entire data center. Now, in the case of databases, it's important to note that any recovery strategy needs to accommodate physical and logical failures. But also, a customer might need to meet regulatory compliance. Now, by physical failures, I'm referring really to things like hardware, networks, or an entire server. And by a logical failure, I mean issues such as data corruption or ill-advised but legitimate user actions. For example, if a customer chooses to delete 1 million records from a table, now as long as there's permission to allow that, the database will happily do it. Now, different businesses may have different regulatory requirements, and they may need to be able to restore data at a particular point in time for auditing purposes. So any strategy based solely on getting the database back up and running in the shortest possible time and with the smallest amount of data loss might not be appropriate for that particular type of business.
And where the DBA plays a key role in this is that they understand exactly what the database needs in order to recover. In databases, consistency is everything. You have lots of tables, lots of data with complex interrelationships, and if you don't restore all of those to the same point in time, you break the relationships and the data becomes unusable. So as you deploy a strategy to provide you your business's recovery objectives that could span multiple different elements across the infrastructure, the DBA needs to be at the center of that, pulling those together to make sure that what gets recovered is a consistent, startable, usable image of the database.
Cool, thank you, Andy. So on to my last question for you guys on this webinar before we take questions from the audience. Sticking with data protection, how can the data within the database be protected from attack, Brendan?
Well, the first line of attack is making sure that only the people who should have access to the data can access it. The database administrator can do this by using permissions, so assigning permissions to either users or groups, and you can do that in database, table, view, or subset level. And these permissions control whether you can insert new data, update existing data, delete, or some users are just allowed to view the data.
Another option is through the network as well. A lot of the applications we work with follow the typical web application DB model, and between each one of those layers we have different firewalls to enforce different access rules and limit the scope of attack for people coming in from internet-facing services.
Yeah. Now, also you've got security policy, and that really should be based around paranoia, and it basically should do as much as it can to prevent any attack, but at the same time make sure that any damage is limited if there is a successful attack. One of the key ways of doing this is encrypting data so that even if someone manages to get hold of it, it's got no value to them because they can't read it. And you can do this in the database, in the operating system, the storage system, or indeed the backup. And also you can do that within the application layer. Now, the most appropriate of these really depends on the business and what uses they are putting the data to. Also, it can matter where the data is actually being held, depending on which country may mean that different regulations are in place. This is something the DBA needs to play a central role in, to make sure that at the same time that we're getting all of this security, we've also got performance, the data is still available, and it's all recoverable.
And finally, I think it's really important that you have a means of auditing the system so that you know what's going on from a security perspective. Being able to see attempted breaches is just as important as being able to identify actual breaches so that you can limit the damage that gets done and you can implement remedial actions before you really get caught out by an issue. So then your security policy can be continually evolving. It's not a set and forget element. It's also really important here that the database administrator works as a part of the bigger infrastructure team so that this auditing and this approach is integrated across all levels in the organization. Another means of making sure you limit the attack vectors available.
Thanks, Andy. I'm sure we all agree that these, at the very least, these mechanisms provide peace of mind that measures are in place to maximize uptime and to protect the database so that those benefits we discussed earlier are obviously becoming increasingly important to businesses. And this, as you mentioned, auditing, there's ever-growing regulatory burden out there, and there's potential hot water for companies that can't comply. I'll just like to summarise, I guess, what we've discussed. It's been a whistle-stop tour of a broad range of topics around database management. That's all focused on that, highlighting the point that the significance of a database within IT infrastructure is really high. It's a cornerstone of many businesses, and without it, the things that you want to focus on, the innovating and being competitive, will be difficult. So we've also mentioned how, in order to maximise and protect this valuable resource, there is a large number of considerations and integration points across various infrastructure teams. That these need constant review and action by, ideally, experts in the database technology that your business is using. I will just take a moment to sort of explain for those who maybe don't know that the managed database service is a service that Claranet offer, and this slide of logos is to some of the people who are trust their critical databases to Claranet, both to host and to manage and experience all of the sort of expertise that you've heard so far. Okay, we've got just a couple of questions. I think this first one will be for Brendan. Thanks to Patrick for raising this. So question number one. From a reporting point of view, which database metrics are most important? And does Claranet have any policy in place on database reporting?
When you say reporting, I'm assuming you're talking about which, like a template that we use. And what we have in place at the moment is we use like a dashboard basically, and that's attached to most of our servers. And within there we have things like page life expectancy, we measure I/O, CPU, also looking at things like long-running queries. It's not just about metrics in terms of things per second, but which queries are taking the longest, because that's the thing that is most key to the customer often, is the actual perception as opposed to numbers.
I mean, Patrick, I think this is a very, very good question actually, and it's one that I find very difficult to answer, because you need to present two different views of the world really. From as the administrator, you need to understand some real nitty-gritty, fine detail about minutiae, which you'll spend all day trying to explain what that actually means to the person consuming the report. But actually, to me, some of that stuff is what is really important in knowing the state of your system. Whereas you bring out some of the higher level statistics that people have got more of a chance of understanding if they're not database savvy. And to me, they don't have as much value, but people need to see what's going on and need to have that help. And it's a real fine balance between what is technically useful and what is understandable from a business perspective. And I don't know the answer either. I've been doing it long enough and I'm still not there.
Okay, thanks guys. Another question has popped up. Increasingly, application designers are choosing to adopt a new model for development around NoSQL databases due to the flexibility they offer, where data is much less structured and the need to be agile is paramount. So to either of you, do you think this affects the role of a DBA? Is it moving the traditional responsibility of theirs to a developer instead?
Yeah, I think that there is the chance that this is moving some of the intelligence that was held with the DBA may now be moving towards the application developer, because the environment is that much more fluid. But I think it's still important to understand that those databases still need to be available, they still need to be up, and you still need to perform well. So all those same characteristics, all the things you have to do around the infrastructure, around data protection, etc., that all still stands true, and you need the DBA as somebody there dedicated to making sure that that platform stays up and available and secure.
I think also as well with NoSQL, it is still relatively new compared to our more mature technologies like SQL Server, and because of that there's an awful lot less in terms of extra tools. For SQL there's masses of tools you can use to help you identify problems. That area isn't quite as mature in NoSQL, and so often DBA might actually have to do more work and get more involved than you would in the SQL Server environment.
Great, thanks guys. I've just got one more question, which is something I've been aware of being asked in another situation. How much control is the customer giving up?
I would suggest almost none. What we are effectively doing is looking after your data. To do that properly, we need to protect it. But at the end of the day, it is yours. And if you need to make any changes on that data, basically, as long as we know what's happening, you can do that. We don't encourage sysadmin rights on a live server at all. But often you have that where a third-party supplier might need to fit a bit of software, and often that comes with a caveat that says we need the SA rights in order to fit it. So under circumstances like that, we can then create a login with SA rights and basically under a controlled environment go in, fit the software, and then remove those SA rights. But as I say, it is at the end of the day your data. We just look after it for you.
Great, thanks guys. Well, I'm going to wrap up now. Thanks for those questions that people handed in and for attending. We will share these slides with everyone who's attended after the call. And just at the back here, I've put in a couple of slides on the Claranet services. We know that many of the customers out there aren't as aware as we'd like them to be of what's on offer from Claranet. So I won't go through these now, but just see if there's anything from looking at these that you perhaps feel that Claranet might be able to advise you on. Right, that's it. I'd like to big thank you to both Brendan and Andy for contributing today, and thank you all for attending. Bye for now.